In section 6.8, we're going to consider something called an indeterminate form, and we're going to use L'Hopital's rule to compute limits involving these indeterminate forms. So we've seen indeterminate forms before. For example, if we wanted to look at the limit as x approaches -1 of x squared plus 3x plus 2 over 2x plus 2, if you plug that -1 in here, you get 1 minus 3 plus 2, which is 0, and in the denominator, -2 plus 2, which is 0. This is form 0 over 0. And remember in Calc 1, when you got form 0 over 0, that meant you needed to do some more work. And many times the more work was some algebra, factoring. And that's what we need to do here. So this is limit x approaches -1. In the numerator, we can FOIL backwards here. So x and x. And we want factors of 2 that add up to 3. So plus 2 plus 1. And then in the denominator, we can factor out a common 2 here. And we'll have left x plus 1. And now the x plus 1s will cancel. And the limits are still equal, remember, because x is approaching -1, it never reaches -1. So even though the expressions are not quite the same, the limits are equal. So this is now limit x approaches -1, x plus 2 over 2. And this is no longer form 0 over 0, so we can just plug that -1 in. -1 plus 2 is 1 over 2, 1/2 for that limit. So now I'm going to do something that seems a little strange. We haven't done this before. And that is I'm going to look at the limit where we take the derivative of the top function and the derivative of the bottom function. So the same limit, but I'm going to differentiate the top and bottom separately and see what happens. So I got a limit as x approaches -1 out in front. And then we differentiate the top. Here we get a 2x plus 3 and a 0. So 2x plus 3. And then in the denominator, derivative 2x is 2, and derivative 2 is 0. And this limit is not form 0 over 0. That's a determinate form. We can tell what happens. It's continuous. You just plug in that -1. So this is going to be -2 plus 3 over 2, which is just 1/2. And check it out, we got the same answer. And that was actually not by chance. That's something called L'Hopital's rule. It says you can differentiate the top and bottom separately. Well, what about this limit? Limit as x goes to 0, 1 minus e to the x over sine x. Well, e to the 0 is 1, so that's approaching 1. So the top looks like 1 minus 1, which is 0. And the bottom, sine of 0, is also approaching 0. That's an indeterminate form. Wonder if L'Hopital's rule works on that also. Well, we'll have to wait and find out.